Hi, this is Alexander Jackson. I am doing a presentation on the use of induced EMF in regenerative braking and suspension systems. I am doing this for a requirement for Physics 2020 through the Tennessee Technological University. My contents include an introduction on why we need regenerative braking and suspension systems, a background on how they work, uh, their applications to braking and suspension systems, and a conclusion. Uh, New transport methods and fuels are being sought after because of the depleted crude oil supply and high carbon emissions from internal combustion engines. Customers are seeing that the prices of oil are too high and that carbon emissions are having a negative effect on the environment, and so they have been buying less fuel, and manufacturers are seeing the desire and the market for hybrid and electric vehicles. The state of the art Tesla Model S, as far as range goes, only has a range of 370 miles. This range is a bit short comparatively to an internal combustion engine with a quick refuel. These short range vehicles are not optimal for long trips, having to make long stops during those trips. Electric vehicles are using regenerative braking systems to recharge, however, to maximize the length of time they can be driving. These systems include both braking and suspension, and they use electromagnetic generators and motional EMF to generate current. Uh, Electromagnetic flux is produced when a conductive material moves through a magnetic field or vice versa. This is done through a rotational generator in electromagnetic regenerative braking, in which magnetic rods or plates are surrounded by coils of wire. This produces an alternating current, but which can be converted with a split ring, which stops the contact momentarily of the conductive material, causing a single polarity. This can be calculated by EMF equals the number of coils times the magnetic field strength times the area of the coils times the angular velocity of the rotating mass. An example of this that most of us are familiar with is an alternator in an internal combustion vehicle. This simply works with a pulley instead of an axle, but the braking system uh, occurs due to Lenz's law, in which there's an opposing force on the mass that's rotating. Here we have a diagram in which the rotating system of the DC electric generator can be seen rotating within two conductive materials with north and south polarity. You can see the split ring that stops the contact momentarily, causing the graph on the right to be a single polarity induced EMF. While the EMF does vary, more coils can be used alongside each other to have less variance in the average EMF over time. Regenerative braking systems use these DC generators on each axle, so you have four on each vehicle. Hydraulic friction braking systems create heat which is dissipated out of the kinetic energy, but electric vehicles harvest the kinetic energy to stop the vehicle. Uh, One experiment yielded 7.939 kilojoules of electricity from just one wheel out of the four, which was 0.3 volts on average over a time of 9 seconds. However, this shows that regenerative systems need a friction supplement braking system. Uh, they don't brake fast enough for emergency stops, as you can see with the 9 second stopping time, and the distance is not or is not short enough either. The low voltage, also at low speeds, does not produce any stopping force because it does not have a voltage that reaches the voltage of the battery or the capacitor that is going into. Another system that can be used to harvest kinetic energy is suspension. Suspension addresses losses due to vibration from unequal surfaces in the road. These include potholes, rocks, or just curves that you're going around. The purpose of suspension is to improve the ride quality of your vehicle, to keep you comfortable. It keeps the tires in contact with the ground, because without that contact, you can't have friction or acceleration. And it reduces the tire deflection, which is the lateral deformation of the tire, which reduces the contact patch of the tire itself. Suspension helps in reducing vibration and dissipating vertical kinetic energy, or kinetic energy in the vertical direction, rather. Here we can see a rough diagram of an EMF, induced EMF suspension system created at the Technical University of Malaysia. EMF for linear motion can be calculated as the absolute value of the EMF equals the number of coils times the magnetic field strength times the length of the coils multiplied by the velocity of the conductive object. The same laws apply as in rotational systems, including a reactive force, in which the current due to Lenz's law creates an opposing force on the rod. This opposing force pushes the rod in both the positive and the negative direction when it exits the coils. So when the vehicle is too low, it will be pushed up, and when the vehicle is too high, it will be pushed downward, just as a strut and a spring system would do. A study from the International Federation of Automatic Control through a university found that two systems both work efficiently. These systems are maximum induced power control, which is an active damping system. The highest, it yielded the highest power return, as you can see, 44 watts from a vehicle traveling at 70 kilometers per hour. They also used another system that yielded 40 watts. A regenerative damper, however, that's a passive damping system, yielded the best dynamic control of the vehicle. So your rolling inertia, which causes vehicles to roll over or to lose contact on one side of the vehicle when turning, was at its lowest with a passive regenerative damper. And also the tire deflection when turning was lower with a passive damping system. So it yielded the best dynamic control, although it gave the least power. Although these aren't used currently on a whole lot of models of vehicles, I suppose that engineers could capture the best aspects with a variable system. I've seen this recently in active aerodynamic systems in F1 races, in which the aerodynamic system responds to the speed and the turning velocity of the car and adjusts to create downforce or less drag from that. In conclusion, current electric vehicles lack range, but they're making use of energy harvesting that internal combustion engines can't. Regenerative braking on many on electric and hybrid models, including the Tesla Model S, are very common. However, regenerative damping systems are not yet common, but they're making advances, and people all over the world are studying them and looking into their feasibility. Induced current is used in multiple facets, not just vehicles, but also in power supply systems of entire cities, and they'll help take clean energy farther, thereby electricity and magnetism definitely affecting and saving our future.